start with 11.3. So 11.3 is called the tangent line problem. All right, so in higher level math, a lot of mathematicians are concerned with when you're looking at a function at a specific point, we want to know at that particular point. So here's 3 different graphs here, right? We've got like a one that rises, falls. This looks like maybe an exponential decay and a parabola. We want to know at these single points P, what is the graph doing at that exact point? Okay, so at point P, this graph has a line that is tangent to the point, and we're concerned with what that line is doing. So if you think of any graph of any function, it's made up of a bunch of points, and each of those points has a certain slope as what it's doing. So if I took, for example, this isn't a wonderful picture, but if I took this, and I drew this point down here, right? My line through that is probably going to be more sloped this way. So it's less of a slope, right? If I took a point in here, it's probably going to have a greater slope because my original function is increasing at a greater rate. If I took a point up here, that line that is tangent to my point has a flat slope. So it's just flat. So what mathematicians want to know is, given any point on my function, what is that point doing? Is it increasing at a great rate? Is it decreasing? Is it flat like this point? There's no inflection on this point. So it says, obviously right here, you can read, but it says, in simple terms, the tangent line to the graph of a function at point P is a line that best approximates the slope of the graph at that particular point. So basically, you're thinking about finding the slope of a point on your graph at any given time. So there's not, depending on what point you pick, the slope's going to be different, right? Obviously, if you look at this parabola, the slope here is going to be a negative slope on the left-hand side. It's going to be, horizontal right here. And then we have a slope that's increasing as we go up the parabola. So it changes over time. Okay. So the big idea is that if we want to find the slope m of a graph of a function at any point is equal to the slope of the tangent line and is given by this equation. So the slope at any point is the limit as h approaches 0 of f of x plus h minus f of x divided by h. I know that's a bunch of numbers, but we'll talk about the math behind it. The big picture is that we call this idea of finding the slope of a point on your function, we actually call that the derivative. So if you notice here the formula is slope equals, the limit as h approaches 0 of this. And then down here we call something called the derivative is the same exact formula. They're the same thing. So the slope and the derivative are essentially the same thing. And the derivative is something in calculus that we spend a lot of time worrying about, what the derivative of a function is and calculating what it is. So the derivative or the slope is just at a particular point on your function. If you draw a tangent line to that point, what is going on? Is my function at that point increasing, increasing with a huge slope, a little slope? Is it horizontal? Is it decreasing? What's going on? So derivative and slope are kind of the same thing, but that's just what we call it in calculus, okay? And then the last piece of that is that this thing called the derivative, which we're going to learn to calculate, can be written several different ways. So once you get your calculus book, you'll look all through it and you'll see this, but the derivative is written with this little f, what is that called? I want to say prime, but that's not right. I have to look what that's called. But the f with a little mark of x. The other second most common way that you see the derivative written is like this, dy over dx. Sometimes you'll see it just like y with a little, I want to say prime, but that just doesn't seem right. And then you have d of x of f of x. So all of those are different ways to indicate the derivative. Okay. So that's kind of the general definition. The idea behind it is that, well, we're going to start off kind of slow. That's how the book works, right? They kind of start off and they build up to finding the slope and then the derivative, which is basically the same thing. So let's zoom in a little bit. And do this. Okay, so the first few questions, they give you a function. They don't tell you what the function is, but they give you a function. Like, for example, number 2, there is a, I don't know what that is. I know this is a cubic equation, but I'm kind of looks cubic, but looks like it flattens out a little bit. But basically, they want to know, can you tell me at this particular point, which looks like in number 2 is 1, 1, what is the slope of your curve at point 1, 1? So what is the slope of your curve at point 1, 1? So this goes back old school algebra 1, back in the day, right? We have the tangent line that's drawn in red. And so that's showing you what the slope at that particular point is at 1, 1. So we can use that, the graphic part, to find the slope at that point. So the slope of a line, right? Old school, change of y over change of x. Okay, or y1 minus y2 over x1 minus x2. So we can just pick some points on here and do our slope formula. So there's a point here on our line that is at 0, 2. There's a point here that is at 2, 0. So our change in slope is our change in y. So let's do 2 minus 0 over, yeah, see, I always get confused. I think I told you this. X1, Y1. I still cannot do slopes in my head. Just do not do them well. All right, so we did Y1 minus Y2, so it should be X1 minus X2. All right, so 2 divided by negative 2 is negative 1. So the slope is negative 1 of that at that particular point for your curve. So far, so good, right? All right, you're like, okay, I can do this. Not a big deal. So then we are going to get to the next piece, right? So it says in exercises 5 through 12, use the limit process to find the slope of the graphs of the functions at the specified point. Use a graphing utility to confirm your result. Okay, so this is where it's going to get a little bit more mathy and complicated. Not hard, just more math. So if we go back over here, we found that the slope is defined as this. So I am going to steal this so I don't have to rewrite it. We'll just put that right up here. Kind of cover all that yuck up. Okay, so the slope is defined as the limit as h approaches 0 of f of x plus h minus f of x over h, right? So let's do this, all right? So, sorry, I was just double checking my notes here before I start launching into all the crazy math. Okay. All right. So let's do number 6. Okay. So number 6 is this function down here. F of x equals 10x minus 2x squared. And we want to find the slope of the graph at 312 to figure out what the slope of the graph is at 312. At x equals 3, y equals 12. So we're going to use this idea that the slope, and we're using the limit process to do it, right? The slope equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, so what this means, and then we know based off our equation that the point that we're doing this is at 312. So we know that we're looking when x equals 3. Okay, so for this slope, right, we want to do the slope as the limit of h approaches 0 of f of x, and instead of x, we're going to write 3 because we know we're at 3. 3 plus h minus the function at 3 divided by h. So because we're doing the limit as h approaches 0, h isn't something that we can plug into our function. It's something that we're going to have to divide out, and you'll see how that kind of works out mathematically. So now what we have to do is we have to figure out what is the value of our functions. What is the value of our function when x equals 3, and what is the value of our function when x equals h plus 3 or 3 plus h, right? So we're going to do the limit as h approaches 0. And now we're going to go back to our function here, right? So you could kind of do these off to the side if you want. It depends how much you want to throw into your actual problem. So I'm going to do them off to the side just so it's not so messy. So the one I'm going to start with is f of 3. So what is the value of my function when x equals 3? Well, it's 10 times 3 minus 2 times 3 squared. So this ends up being 30 minus 2 times 9, or 30 minus 18, or 12. Okay, so that value there is 12. So we got that. I know when I'm going to put in 12 up here, up there. Okay. The second part is we have to figure out what is f of h plus 3. So I'm going to keep working off to the side down here. Okay, so what is f of, I'm going to do h plus 3 because it just feels wrong to write 3 plus h, but they mean the same thing, right? You can add in any order. This one's going to be a little bit more tricky, right? So in my function up here, it's 10 times x. So instead of x, I'm going to put in 10 times h plus 3 minus 2 times h plus 3 squared. Okay, so I could then take this and I could plug it into so I could put this up here and then minus 12 divided by h. I'm going to simplify this a little bit though before I put it into my limit function. Okay, so I see over here that I have an h plus 3 squared, and I have 10 times h plus 3, so I'm going to distribute. So I'm going to do 10h plus 30, right? I have minus 2, and then I've got to FOIL this h plus 3. So I've got h squared plus 6h plus 9 or 10h plus 30, and then I've got to distribute my -2, minus 2h squared minus 12h minus 18. Maybe I'll simplify it one more step, and then I'm going to throw it back into my limit equation. So I've got negative 2h squared, and then I've got a 10h and a negative 12h, so negative 2h. Now I've got 13 minus 18, 30 minus 18, sorry, plus 12. So I'm going to take this, and I'm going to plug it back into my limit equation. And my paper's not even big enough. Ooh, well, maybe I can do this. Thanks, technology. Okay. I'm going to plug this back in for my f of 3 plus h, or h plus 3, right? And then I need to subtract my f of 3. So I'm going to subtract this down here, my f of 3, right? Minus 12 divided by h. Promise we're almost getting there. The limit as, oops, I don't need a line under that. H approaches 0. Oh, let's simplify a little bit. I have negative 2h squared minus 2h over h, right? Because 12 minus 12 is 0. Okay, that's good. I'm encroaching down here. All right. Limit as h approaches 0. Well, if I have this h on the bottom, the limit is not going to work, right? The limit's not going to, it's not going to exist. But it looks like I can divide an h out of both things, right? So I could rewrite this as negative 2h minus 2. If I divide h out of both of those. Now, if I put as h approaches 0, I get that the limit as h approaches 0 of negative 2 times 0 minus 2 is negative 2. So this is the slope of the line at 312. Voila, yay. Who thought number 6 would have this much work? You should see this section has a lot of typing to it. So if you go to Desmos, somewhere I have Desmos. Okay, if you go to Desmos and I type in, oh, by the way, Connor, I don't know, I was awfully excited about this. I know this is geeky. So if I type in like 5 times, this has nothing to do with whatever. It has nothing to do with math. Desmos upgraded. So if you upgrade your app, look, it actually puts a little space in where that like breaks out the hundreds and thousands and million and all that. So I was excited because I'm always counting out. Okay. So if I graph my original function, 10x minus 2x squared, okay, this is a parabola, right? It's a parabola at 312, 1, 2, 3, 12 up here. Okay, at 312, I'm saying that the slope of my line is negative 2, which seems reasonable because at that point my graph is falling, right? It's not increasing. So it seems like at that point my graph should be falling. So let's at least graph a line that y equals negative 2x. Let's graph a line with that slope. I don't think I can move it. So I need to shift my graph to the right, more than that. 18. Oh, there we go. All right, so I just was playing with a graph, right, to find a line with a slope of negative 2, and it looks like they actually meet up okay. So yeah, right there at 312, you can see that the slope of my graph right there is negative 2. Well, it looks like it's a reasonable request for that, right? So that's the idea of how to find the slope. Doing the problem, you can see, is a lot of math because if you have any values that are squared, then you've got a whole lot of work to do with it, right? So basically what you're doing is you're finding the function at its x value where you want to find the slope or the derivative. And then you're finding it at the x value plus some constant h or some value h. And then you're dividing the h out and finding the limit as h approaches 0. So you can use this technique to find the slope and then therefore the derivative at several points. So, does that look fun, Connor?
Maybe.
Maybe. Oh no, you said you weren't able to hear me before. Did I come back on?
Yeah, it was something with my mic and headset.
Okay. Sorry about that. I totally missed that. Oh, hi, Mackenzie. So what I think you can probably try a couple of those, but what we're going to do in class on Monday is we're going to just do a lot of math to go through and find slopes and then eventually find derivatives of the functions at certain points. So I think that's where we'll stop today, or else I'll just be re-explaining for you guys again. So I think that's it. I hope you guys have a good day.
Thank you.
All right. Thanks, Connor. Thanks, Mackenzie.
Bye.
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 Bye.